In this video, we will be talking about friction. Have you ever walked on ice? It's really tough to keep yourself from sliding and losing control. But when you walk on pavement or dirt, it is much easier to control your movement. Do you know why?
It has to do with friction. Friction is the force that resists movement. There is friction between all touching objects sliding over each other. Even the smoothest looking surfaces are very rough on a microscopic level. So when we slide them over each other, there will always be a friction force working against that movement. When you walk on ice, there's very low friction, so there's very little force working against your feet sliding. Whereas on pavement, there is much more friction, so you can control your feet. But why does ice have so little friction?
There are two factors that affect the amount of friction between objects. One is the roughness of the object, and the other is the normal force, or the force perpendicular to the object's motion, pushing the sides together. The most common example of normal force is the ground pushing up to balance out the force of gravity and keep the object from falling. To find the force of friction, you simply multiply the normal force by the coefficient of friction, or mu. This is easy to remember because it makes the word fun. F equals UN. Now let's try a practice problem using that equation. If I push a block that weighs 5 kilograms along a flat patch of ice and the surface has a coefficient of friction of 0.3, what is the force of friction pushing against that object? To find that force of friction, all you have to do is multiply the coefficient, 0.3, by the normal force. But remember, 5 kilograms is a mass, not a force. So first we will have to find the resulting force due to gravity. And you find the force of gravity, or the weight, by multiplying the mass by the acceleration, or 5 kilograms times gravity's acceleration, which is 9.81 meters per second squared, which turns out to be 49.05 newtons. Because that is the force gravity pushes the block down, it is also the force the ice pushes up on the block, or the normal force. So we can plug that normal force and coefficient of friction into the equation. F equals UN, and get 0.3 times 49.05 newtons equals 14.72 newtons. So that is the force of friction working against the block's movement on ice.
That type of friction is called kinetic friction, and it works against moving objects. You have probably noticed that it's a lot harder to initially push a heavy object against a lot of friction than it is to keep that object moving against that friction. That is because a non-moving object has static friction preventing movement, which is always greater than kinetic friction. So static friction prevents potential movement, whereas kinetic friction works against movement which has already started. For any two surfaces in contact, there is both a coefficient of static friction and a coefficient of kinetic friction.
To summarize, friction is the force working against movement. There are two types of friction: static friction, which works to keep objects in place, and kinetic friction, which works to slow objects down. Static friction is always greater than kinetic for a certain surface. To solve for friction, you use the equation frictional force equals coefficient of friction times the normal force, or F equals mu n.
To learn more about this topic, search friction on ck12.org.